Hello class, welcome to the next segment in Lab 3, and in this segment we're going to take a look at MatPlotLib.pyplot and take a look at some of the functions that you'll need to know in order to complete the project. So just to start things off, if you want to create some pretty graphs, then you're going to need to bring MatPlotLib into your program, so that's what this import statement on line 3 does. And again, by having this as statement here, we can reference this module which contains a lot of functions that can create graphs for us. By using the as function here, we shorten this really long name to something that's really quick and easy to type. So that saves our fingers a lot of work when we're going to type stuff on the keyboard. And this other import statement on line 4, that's also important to have, but it's not really important to know what it does. If you really want to know what it does, it basically allows us to create a color bar that has our own colors on it. So we can customize our color bars on our graphs. And you'll see what exactly I mean by that a little bit later on, but for now, that's basically what this module does, is it allows us to customize the colors on our color bars. And here we've got empty array, which is basically the same exact array that we had in segment 4 when we were introducing arrays. So again, this creates an empty array that is 10 rows by 5 columns. And we have the same statements here, so top left hand element is going to be set to 20, and then the 0th row in the column number 1 will be set to 10, and then row number 1, column number 0 will be set to 5. And here I have some other stuff on line 12 and 13, x list, y list, and you see that's equal to something. And we'll get back to that in just a little bit. But for now, I do want to go and focus on this function right here, PLT. Again, that PLT is the same PLT that shows up here. PLT.contourF. This is a function that allows you to create a contour plot that fills in the contours. So the whole idea behind a contour plot is you draw a bunch of lines. Everything on one side of the line is less than a particular value, and everything on the other side of the line is greater than a particular value, or vice versa. And the way that the contour plot works is you give it a list of values that go on the x-axis. So that's the first value that you give the contour function. The second value you give the contour function is a list of values that you put on the y-axis. And then finally, the third value that you give the contour function is the two-dimensional data set that you want to actually contour. So that's how this works. So again, list of x values, list of y values, and then the actual data that you want the program to contour. And there's a bunch of other stuff in here. There's not a whole lot. You really don't have to worry a whole lot about what's going on here. A lot of this stuff is already set up for you. So the color bar and everything is already set up. The main thing that you want to worry about is where you're going to save the plot, and also this bit on line 30. The main thing you want to focus on is that this first value that appears in this axs.mshow, the very first value that appears in that function has to be the same value that appears up here. So just make sure that you have a variable pointing to your data set within this function here on line 30. That means just make sure that's the very first thing. Then you don't have to change anything else. And then also make sure that vmin and vmax are somewhere. Basically, this vmin and vmax, this allows you to set the bounds on your color bar, and I'll illustrate that really shortly. And then finally, this plt.savefig, that basically allows you to save a copy of your image to a file, which is really nice. So in this case, this is going to save the plot that we generate to a file called example.png, and this image file will be saved to the same folder that our Python file is located in. So our Python file is called s9.py, which is located in this folder. So that's where the image, example.png, that's where the resulting plot is going to be saved. And if we run that, you can see we get some lovely graphics appearing in the console. And if we go to the folder, you can see we now have a file here called example.png. And if we want to open that, we can see we actually do have some sort of result here. Now going back to the vmin and vmax, you'll notice that this vmin value corresponds to the lower bound on the color bar here. You can see this color bar is basically, it acts like a legend. So it allows you to pick out which colors represent what values. So in this case, a value of 10 or a positive value would be represented by something in red, and a negative value would be represented by something in blue. And you'll notice that Vmax, the positive 10, corresponds to the upper bound on the color bar. So just a useful bit of information so that you know what bounds, so you know how to adjust the bounds on your color bar when you go to generate your final graph. Now, I want to go ahead and now I want to talk a little bit more about what exactly is going on here on lines 12 and 13. So let me actually go ahead and disable everything down here so that we can focus on what exactly is going on here on lines 12 and line 13. What this does on line 12, actually let me enable that. I'll go ahead and enable that. What this does on line 12, what this does is this creates a list that starts at 0 and then goes up to but not including 4. So this creates a whole list of items. The first item will be 0, the next item will be 1, then 2, then 3, then 4, up to but not including 5. And what this does on line 13 is this does a similar thing. Starts at 0, but this time goes up to but not including 10. So this list on line 12 will actually give me a list that is 5 items long, and I can go ahead and prove that to you by telling the computer to print it out. And there's our list, and then I can do the same thing for Y list. So you can see how both of these lists, this list has something that's 5 items long, and this list has something that's 10 items long. Now, a very common mistake that I see when working with MatPlotLib is the temptation to do something like this. And I'll go ahead and ask you, how many items long is this list? The answer is 2. Even though it might be tempting to call this a list that might be 5 items long, it is in fact 2 items long. And if you do something like this, you will get this lovely error message, length of X must be number of columns in Z. What this basically means is that you screwed up somewhere. But to understand why this doesn't work, let's actually take a look at a bit more of a visual cue here. So this is the empty array that we are plotting using the contour function. And you'll notice that, you'll remember that we have 5 columns, column 0, 1, 2, 3, 4, and we have 10 rows, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 rows there. Now, when you're using the contour functions, and this also applies to pretty much anything else in MatPlotLib, when you go to give it the values on your x-axis, then you must get the values that you put in for the x-axis must match up to the values that you're actually plotting. So in this case, we are contouring. So in this case, we're trying to contour an array that has 10 rows by 5 columns. And remember that the rows represent our y values, and the columns the columns represent our x values. So if we have 10 rows, that means our list of y values must be 10 items long, so that each row has a y value that it can be married up to. And the same thing also applies to the columns. So if you have something that has 5 columns in it, then you must also give it a list on the x-axis that is 5 items long. That's what we had up here in lines 12 and 13. So our X list had something that was 5 items long, which corresponds to the 5 columns that we gave our array of data. And our Y list has something that is 10 items long, which corresponds to the number of rows. So X list, remember what the values for that were. It went 0, 1, 2, 3, 4. And you can see how each item in X list can be married up to a column in our empty array. So 0 goes to 0, 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4. So every column in our array of data that we're plotting can be married up to an item in X list. That's why X list, that's why there's that restriction involved. And I'll show you how the computer actually interprets this when you don't do things correctly. So when you do that common mistake that I illustrated. And similarly for the Y list, you can see how each item contained within my list can be married up to a row contained within the data that we're plotting. So Y list, this first entry in Y list, which is 0, can be married up to row 0. Y list in 1 can be married up to row 1. And you can see how there's a one-to-one correspondence here. For every item in Y list, there is a corresponding row in empty array. That is our data set that we're plotting. And for every item in X list, there is a corresponding column in the data that we're actually plotting. Now, and of course this all works out as we demonstrated. Now, let's see what happens if you do that really common mistake. So if you make X list be 0, 5, which is a list that has 2 items in it. So we've got one item that goes to column 0, we've got one item that goes to column 1, And unfortunately, columns 2, 3, and 4 are very lonely. They don't have a value in XList to be married up to. So that's going to give you this error message. And you see the boxes here are colored red because the computer was looking for data there, but it didn't find it. So that's why it gave you that lovely error message. And similarly, when you have YList, we have one value that we can marry up to row 0. We have another value that we can marry up to row 1. But rows 2 through 9, yeah, they're pretty lonely. They don't have a value in YList to be married up to. And the computer doesn't like lonely rows and columns, so it's going to give you that error message. So that's just not going to work. That's why we get this error message here. So in short, if I had to summarize this, that last several minutes in just a couple sentences, don't do this, do this. In fact, let me go ahead and uncomment that so that's a little bit more clear. Don't do this instead. If you do this, you're going to be filled with sadness and frustration because you'll just get this error message over and over again. Just make sure that the values, this list that you give the contour function XList, make sure that list has the same number of items as there are columns in the data set that you're plotting. And make sure that the YList that you give the contour function, make sure that there are the same number of items in YList as there are rows in the data set that you're actually trying to plot. So that's going to do it for the bits of MatPlotLib that you'll need to know to complete the project. And in the final segment, we will talk about how to actually start calculating temperature gradients on a discrete data set, which is going to be the main focus for this project. So with that, I will see you in the final segment.